This video focuses on balancing chemical equations using oxidation numbers. This is, in fact, a really important segment in chemistry because one reason is many children don't understand how to do this balancing work of chemical equations using oxidation numbers. The second point is this part always comes in exams. And third point is there are chemical reactions which cannot be balanced using simple observation methods. We need to use oxidation numbers to balance chemical equations. This is because, except very, very few, most chemical reactions are of redox types. Now, when I say redox types, it contains two reactions. First one is, if I take oxidation first, electrons are released during oxidation reactions. And when an oxidation reaction occurs by releasing electrons, there's another reaction where electrons are gained during reduction reactions. So when one species in a chemical reaction releases electrons or give up electrons, participating in oxidation reaction, in the same medium, there's another species which undergoes reduction by obtaining electrons. So when you get a reaction system where one removes electrons, another one takes electrons, it becomes a reduction reaction and an oxidation reaction happening together. So a redox reaction comprises of a reduction half reaction and an oxidation half reaction. Let's try to find out how we can apply this using oxidation number to balance one or two reactions. I would like to use the first reaction between iron 2 plus ions and potassium manganate 7 in acidic medium. I've used iron 2 ions in green because iron 2 solutions are greenish, and potassium manganate 7 I have used in purple because the color of potassium permanganate is purple. And this reaction occurs between iron 2 ions and potassium manganate in acidic medium. For the convenience in my discussion, I will use KMnO4 as MnO4 minus because the potassium ion is not going to participate in the reaction. It is the MnO4 minus part, manganate 7 ion, which is going to participate in this reaction. If I push it up a little bit, let's see how MnO4 minus manganate 7 ion is going to react with Fe2 plus ions in the medium of hydrogen ions, in other words, acidic medium, to produce MnO4 minus goes to Mn2 plus. And Fe2 plus goes to Fe3 plus. Now here, Fe2 plus I had written Fe3 plus as Fe2 plus. I just corrected that. When you get this equation first, MnO4 minus ions react with Fe2 plus in acidic medium to produce Mn2 plus and Mn3 plus. I say in a redox reaction, always a reduction and oxidation reaction. Two reactions happen. If you see this clearly in this, you can see Fe2 plus. Fe2 plus goes to Fe3 plus. In the meantime, MnO4 minus goes to Mn2 plus. This MnO4 minus going to Mn2 plus is a reduction. It's a reduction reaction. And then Fe2 plus going to Fe3 plus is an oxidation reaction. Now we have two reactions, reduction and oxidation. How are we going to balance this chemical equation using oxidation number method? This work begins by calculating the oxidation number of substances which reduce and the oxidation number of substances which oxidize. You can see here manganese oxidation number in MnO4 minus. By assuming the oxidation number of manganese to be X and oxygen atom, one oxygen has oxygen oxidation number is -2. Likewise, there are 4 oxygen atoms. When you add the oxidation number of all these species, you must get a negative overall charge. So X plus is -2 into 4 is equal to -8 is equal to -1. You can solve for X and get 7. Oxidation of manganese is +7. So I write over here, manganese oxidation number is +7. And on the right-hand side, on the product side, manganese oxidation number is +2. What has happened to oxidation number? It has gone from +7 to +2. How do you think oxidation number can go from +7 to +2? Only one way. It is by gaining 5 electrons. If you gain 5 electrons, oxidation number 7 goes to +7 goes to +2. Similarly, if I go to the reaction where this oxidation occurs, Fe2 plus goes to Fe3 plus. When oxidation number goes from +2, anion, +2 to +3, oxidation number has increased. It is because it has given 1 electron out. Given 1 electron. What I told earlier was in a chemical reaction, in a redox reaction, when one atom gives some electrons out in oxidation reaction, the substance which is reducing has to get those electrons. As the same number of electrons must be given and the same number of electrons must be taken. So I modify this reaction a little bit to make the electron number taken and given equal. Because this one gains MnO4 minus moving to Mn2 plus, gain 5 electrons, I have to make sure that Fe2 plus going to Fe3 plus also gives 5 electrons. There's only one way to do it. You multiply given 1 electron by 5. So gain electron number is 5. Given electron number, 1 into 5 is 5. Earlier, I wrote 1 electron for 1 Fe2 plus to go to Fe3 plus. But because I multiply this by 5, I also should multiply Fe3 plus side by 5. Fe2 plus side is also to be multiplied by 5. Now the ion number is balanced. Mn, 1 on the left-hand side, 1 on the right-hand side. It is also balanced chemical equation. Balanced chemical equation in terms of manganese ion, Fe2 plus. But we have hydrogen on the left-hand side. You should know with proper understanding why we are going to add hydrogen into this. It is because manganese ion has oxygen. 4 oxygen atoms are there. But on the product side, only manganese 2 plus is there. What has happened to oxygen? The oxygen has been taken away. The duty of this hydrogen is to take this oxygen away. When hydrogen reacts with oxygen, you know what happens? Water molecule is formed. So I write H2O over here. Because 4 oxygen atoms from manganese ions are removed, it's not difficult to understand that there should be 4 water molecules. 4 water molecules contain 4 oxygen. But the addition of 4 water molecules to the right-hand side give me a value of 8 4 hydrogen atoms. 8 hydrogen. But on the left-hand side, we have only 1 hydrogen. So multiply hydrogen number by 8. Nothing is a perfect reaction. Everything is balanced. Make sure before you finalize your work, you should check the charges. Charges also must be balanced. Here we have a total of plus 10. Here we have a total of plus 8. When plus 10 and plus 8 are added together, we get plus 18. On the right-hand side, we have Mn2 plus, plus 2. And here Fe3 plus. Fe3 plus into 5, 15 plus. Here we have 17 plus. 17 plus. That's a problem with balancing. Oh, no, I'm okay. Because now you will see plus 17 on the right-hand side, plus 18 on the left-hand side. But don't remember this negative charge. For the negative charge, 1 plus charge will decrease. And then it's a perfectly balanced equation. This is how we balance the chemical reaction between iron 2 plus ions and potassium manganate in acidic medium. It's pretty easy. Let's discuss some second example. In the second example, we have a reaction between oxalate ions and potassium manganate 7 ions. This also happens in acidic medium. Oxalate ion is given here. It is actually a dicarboxylate ion. You have 2 carbon atoms in the middle with 1 carboxylate ion on the right-hand side and another carboxylate ion on the left-hand side. They are connected together. Oxalate ions can produce carbon dioxide, while manganate 7 ions change to manganese ions in acidic medium. This reaction happens in acidic medium, similar to the first reaction. When oxalate ions react with MnO4 minus in acidic medium, you can see the reaction producing carbon dioxide Mn2 plus. We have to find out what happens to these substances when the reaction occurs in terms of reduction and oxidation. We'll see what happens to oxalate ions. Initially, I'll try to find out the oxidation number of carbon in the oxalate ion. There are 2 carbon atoms. I do know the oxidation number of carbon atoms. So for the 2 carbon atoms, I write 2x plus, there are 4 oxygen atoms, 1, 2, 3, 4. 4 oxygen means minus 2 into 4. Overall charge of the ion is minus 2. So we have 2x equals to, this is minus 8. When it goes to the other side, it becomes plus 8 minus 2. You solve it to get x is equal to plus 3. So carbon number, oxidation number of carbon is plus 3. And over there, carbon oxidation number is plus 4. So oxidation number goes from plus 3 to plus 4. It is oxidation. We did the work early also. Manganese oxidation number is plus 7. Here manganese oxidation number is plus 2. Here we see reduction. We see how many electrons are released during this oxidation. Carbon oxidation number goes from plus 3 to plus 4. So it has removed one electron. Plus 3 to plus 4, it has removed one electron. But here we have 2 carbon atoms. I have done the calculation for 1 carbon. For 2 carbons, I must write 2 carbon dioxide over here. And how many electrons are lost? For 1 carbon, 1 electron is lost. For 2 carbon, we can see 2 electrons lost. And here for reduction, Mn plus 7 goes to plus 2. It has gained 5 electrons. 5 electrons gain. Again, remember, a chemical reaction cannot happen when unequal numbers of electrons get exchanged. So I had to make sure to make these electron numbers equal. Here we have 2 electrons lost. Here we have 5 electrons gained. So multiply this 2 electron by 5. When you multiply this by 5, I had to write oxalate ion 5. And here we have 2. When you multiply by 5, it becomes 10. So I cut this 2 and write 10. 10 carbon dioxide. And then when you multiply oxidation side by 2, reduction side must be multiplied by 2. So 2 into 5 becomes 10 electrons. Not enough. You have to multiply manganese 2 plus by 2. MnO4 minus also by 2. Again, the usual theory. Why do you have hydrogen over here? It is to remove oxygen. How many oxygen are there on the left-hand side with MnO4 minus? 8 oxygen atoms. So on the product side, we can write 8 H2 because oxygen goes out in the form of water. For that, hydrogen is also needed. Let's see on the right-hand side, how many hydrogen are there? 16 hydrogen. So I multiply this one by 16. This is the balanced chemical reaction between oxalate ions and manganese 7 ions. You can count the number of atoms on either side and can make sure that all the atoms are balanced. As I said at the end of the reaction number 1. This is not a big deal. This is something very, very simple. It's a matter of just getting to know how to do it. The work is very simple. Our third reaction is, again, another important reaction. The most important thing about this reaction is that in exams, you are just asked to write balance equation, or you have to use the balance chemical equation for the reaction that happens between chlorine with hot concentrated sodium hydroxide. That is the first importance. It comes in exams. The second important thing is that this is not a normal redox reaction. This is a disproportionate reaction. What is a disproportionate reaction? The same species, in this case chlorine, undergoes both oxidation and reduction. In the earlier two examples we discussed, when one species undergoes reduction, another species undergoes oxidation. In this case, the same thing, chlorine, undergoes oxidation and reduction. So we call it a disproportionate reaction. In this disproportionate reaction, make sure that we have to use hot concentrated sodium hydroxide, chlorine, react with sodium hydroxide. And the products are going to be sodium chloride is one product, NaClO3, and what is also produced. This NaClO3 is called sodium chloride 5 ions. In fact, by giving you the name sodium chloride 5 ions, I'm also telling you the oxidation number of chlorine in this sodium chloride. If you take this equation again, okay, see, chlorine reacts with sodium hydroxide to produce sodium chloride, and water. We'll see what happens to oxidation number when chlorine forms sodium chloride and sodium chloride. You know the oxidation number of chlorine on the left-hand side is 0 because it is in uncombined form, 0. But here in sodium chloride, we have the oxidation number of chlorine, -1. I'll try to finish this part first. When chlorine goes from oxidation number 0 to -1, it is reduction. For this reduction, what happens to electron? When a chlorine atom goes from 0 to -1, it gains 1 electron. Gains 1 electron. Now go to the other one. Chlorine goes from oxidation number 0 to, this is +5. It's given in the question, +5. So when you go from 0 to +5, what happens to electron? It is oxidation. In oxidation, electrons are lost. Here in this case, the number of electrons is 5. Lost 5 electrons. Now we have that problem again, don't we? Now here, in reduction, if you gain 1 electron, in oxidation, if you lose 5 electrons, we have to multiply this one by 5. Why do we multiply this one by 5? To make the electron number equal. In the earlier cases, when you multiply by 5, you multiply both the sides by 5. Why? To balance the atoms. You can simply think, if you multiply, let's say, the chlorine on the left-hand side like this, then we are going to have a problem. What is the problem? When you write 5 on the left-hand side, we have 10 chlorine atoms. Now on the right-hand side, there are 2 species with chlorine atoms. How are we going to balance this side, the sodium chloride and sodium chloride, to make it equal to 5 electrons? Therefore, I don't do it in this manner. I remove it. You understand what I'm telling? Because we have chlorine only in one place on the left-hand side, and chlorine is available in two species on the right-hand side, if I try to balance the left-hand side by adding 5 electrons, balancing chlorine on the right-hand side will be difficult because there are two places. Which one is going to be multiplied by which one is going to be a problem for us? So I don't multiply the left-hand side by 5. But somehow we have to do this work. So we go to the product side and multiply by 5. That's it. Now you can see on the right-hand side, in sodium chloride, we have 5 sodium. In sodium chloride, we have 1 sodium. Altogether, there are 6 sodium. Go to the left-hand side and draw 6 in front of sodium hydroxide. This is to balance sodium. Now let's go to chlorine. In sodium chloride, we have 5 chlorine. Sodium chloride, we have 1 chlorine. Altogether, 6 chlorine. So you go to the left-hand side where we have CO2. To make it 6 electrons, you multiply by 3. We have one more thing to balance. We have 6 sodium hydroxide. 6 sodium hydroxide means 6 hydrogen. On the right-hand side, we have hydrogen, only 2. So you multiply this by 3. So hydrogen number is also balanced. If you balance sodium, chlorine, and hydrogen, oxygen atoms get automatically balanced. You can check it out and see how accurate this balancing has occurred. So under reaction number 3, in addition to balancing chemical reactions, we also found out that these reactions are of a particular type called disproportionate reaction. For your exam, you should know the meaning of a disproportionate reaction. It is a reaction where the same species don't write the same element. Same species, here it is chlorine, undergoing both oxidation and reduction. So in the third part, we studied how to balance the chemical equation by oxidation number method. Plus, we learned some additional thing. It's a definition for disproportionate reaction. These are really important parts in your syllabus. You have a chance to learn about this balancing method. In this reaction, we can see a copper metal reacting with moderately concentrated nitric acid to produce copper 2 nitrate, nitrogen dioxide, and water. Copper react with HNO3 to produce copper nitrate, nitrogen dioxide, and water. This nitrogen dioxide is a brown gas. So we can see the reaction system bubbling and giving brown gas. But then we'll see how to balance this equation. I've taken the reaction written twice. In the lower one, we'll try to balance the equation. Let's see what happens to copper in this reaction. And then nitrogen. Because copper is in uncombined form on the left-hand side, its oxidation number is 0. On the right-hand side, the heading also says copper 2 nitrate. Copper 2 because copper oxidation number is +2. Here, copper undergoes oxidation. In this oxidation, 2 electrons are removed. So I write 2 electrons lost. And then what about the nitrogen? Nitrogen is on the left-hand side in the nitrate ion. I will remove the hydrogen ion and take NO3 for the oxidation number calculation for nitrogen. Nitrate is NO3 minus. Oxidation number of nitrogen is X. There are 3 oxygen. 1 oxygen has -2 times 3. X plus, straight away I will write -2 into 3 as -6. It is equal to -1. So final answer gives you the oxidation number for nitrogen is +5. So oxidation number of nitrogen here is +5. If you go to the right-hand side, nitrogen is available in 2 places, with copper nitrate and nitrogen dioxide. But I don't touch copper nitrate because in nitric acid we have NO3. In copper nitrate also we have NO3. So there's no way how oxidation number of nitrogen changes from nitric acid to copper nitrate. But there's a clear indication that oxidation number has changed in nitrogen over here with 2 oxygen atoms. If I write +4 for nitrogen, I don't think it's difficult for you. What happens to oxygen now? Nitrogen, it undergoes reduction. Right up there, reduction. In this reduction, you gain 1 electron. 1 electron is gained. Because the gain electron number and lost electron number are not equal, here 2 electrons, I will multiply this 1 electron gain by 2. And then I'm not going to multiply the left-hand side by 2. Instead, I multiply the right-hand side by 2. Because if I write 2 over here, actually, when you look at this equation, the point in adding numbers is to balance the equation. If you think logically, on the right-hand side, we have in copper nitrate, there are 2 nitrogen. In nitrogen dioxide, there are 2 nitrogen. I'm sorry, before adding 2, altogether there are 3 nitrogen. But on the left-hand side, only 1 nitrogen. If you multiply left-hand side by 2, you don't get nitrogen number balance. So I simply write the nitrogen dioxide 2. Then I can see on the right-hand side, we have nitrogen 2 here, 2 here, 4. So I can write 4 over here in front of nitric acid to make nitrogen number equal. And the last step, we have 4 hydrogen. But on the right-hand side, there are only 2 hydrogens. So you multiply, this one is 2. Multiply water by 2. Balance. Another easy work. And in the next example, we'll see another reaction between nitric acid and copper metal. You can see in our next reaction also, the question number 5. Copper metal react with nitric acid to produce copper 2 nitrate, nitrogen monoxide, and water, pretty much similar to the earlier case. But here, when copper react with HNO3, here we have copper nitrate, nitrogen dioxide, and water. Straight away, we'll go to the determination of oxidation numbers first. Oxidation number calculation has to be done for copper and nitrogen. Same as before, copper oxidation number is 0 on the left-hand side, but here this is +2. There you have oxidation. If it is oxidation, you know it is loss of electrons. I write 2 electrons lost. And then nitrogen oxidation number in HNO3 is +5. Oxidation number of nitrogen in NO2 is +4. You can see from +5 to +4, reduction occurs. I think I'm making a mistake here. Mistake is, this is not nitrogen dioxide. I'm writing here nitrogen monoxide. So let me remove this 2. And this +4 also should change to +2. +2. However, it is reduction. And when you go from +5 to +2, it is reduction. 3 electrons are 3 electrons gain. Now that multiplication begins. Because we have for oxidation 2 electrons lost and here 3 electrons gain, I multiply this one by 2 and this side by 3. Okay. You can see here, because I multiply the copper part by 3, I multiply this side by 3, product side also by 3, because copper is available only in one species on the left-hand side and also only in one species on the right-hand side. So that sort of things can be multiplied very easily. And the nitrogen case, when you multiply by 2, remember again, we are not going to multiply the HNO3. We go to the side where there are 2 species with nitrogen, and you multiply this one by 2. Now you can count the number of nitrogen. On the right-hand side, we have 2 times 3 is 6 plus 2, 8. There are 8 nitrogen. So why don't you multiply nitric acid by 8 to balance the nitrogen? And that makes hydrogen number on the left-hand side 8. And we have on the product side only 2 hydrogen. So you multiply this by 4. Done. I think question by question, the difficulty in this balancing chemical equations become, lesser. I think discussing 5 questions at a stretch must give you a lot of knowledge. You should be able to handle the questions yourself on your own. At the end of the discussion that we had, you can see whether this reaction can be balanced. Fe2 plus and dichromate ions to produce Fe3 plus and chromium 3 plus ions in acidic medium. Easy, you can do it. This is the end of this presentation. If you have any question, you can put the question to me.